research methods and techniques in architecture and planning. Before commencing the sessions, I would like to inform you the following rules and regulations related to in the sessions of the program. Each day's session shall be carried on the same Zoom link. You are requested to log in, join the meeting with the name with which you have registered in this program. Kindly avoid logging into the meeting with any other name apart from your original name. You are requested to log in 15 minutes prior to the session to ensure an experience throughout the event. Kindly keep your microphone on mute and video camera off while the experts are in progress. In case you have any queries, questions while a session is going on, you can type in the chat box or can ask them question answer duration at the end of the session. E-certificates will only be provided to the participants of this program who have paid the registration fee, nominated by their institute under CTP, and fulfill 100% attendance criteria, as well as scored more than 60% on the MCQ test, which is scheduled on 12th January 2024 from 4:30 to 5:30 p.m. Attendance shall be counted individually for all the sessions scheduled during a single day. Today, to begin with the day 3, we have 2 sessions and there is little change in the order of the sessions. First session is by Dr. K. Mohan sir on experimental methods in architectural research, and the second session is by Dr. Nand Kumar sir on research methods and techniques in planning. So let's begin the first session of the day with the presentation by Professor Dr. K. Mohan sir. Professor Dr. K. Mohan sir obtained his BArch from JNTU Hyderabad, MArch from IIT Kharagpur, and PhD from IIT Roorkee. As a part of his doctoral work, he carried out extensive wind tunnel tests on tall buildings at the University of Auckland, New Zealand. He has more than 30 years of experience and is currently working as Dean and HOD at the Faculty of Architecture, Sri Shiv University, Cuttack. So now, sir will be presenting the topic experimental methods in architectural research. Welcome, sir. Sir, you are on mute.
Okay, thank you, Anisha.
Yes, sir.
And once again, welcome to all the participants for the third day. And today I'll be telling you something about experimental methods in architectural research. So I'll start sharing my screen. So am I audible and visible?
Yes, sir. Yes, sir.
Yes, sir.
Okay, so yesterday and day before, we had some very interesting sessions, and different types of methods of carrying out research was told by the speakers. One method which is not very frequently told is about the experimental methods, because it's quite expensive. First of all, carrying out experiments is a expensive affair, and most of the research is either qualitative or quantitative, and fundamental basic research is quite less in our country. But however, it plays a very important role, and without experimental methods in research, one cannot formulate many of the theories which are there in architecture. For example, one of the best examples you might have seen is the ECBC code, in which you have energy conservation building code, where a lot of things are there which make it easy for a designer who's calculating the energy audit of a building. But then these are not just written like that. After very careful experimental observations, they have come up with certain things like wall-window ratio on so many other aspects. So most of these methods, experimental methods, help in formulating theory and also in like confirming certain hypotheses that you may have. And one of the it may take a little bit of time, but one of the best examples that I can cite today, where is the COVID vaccine. Like just imagine, like we were able to, India was able to develop the COVID vaccine in a maybe period of 1 year, and we done through a lot of experiments, and not only experiments. After that, the medicine has to be tested on many people or animals and all this, and the safety of that particular vaccine, in record time it was done, and that saved so many lives. Suppose the vaccine was not there, then so many people died. So let's proceed. I'll just very briefly tell, because you already know about this. So what is research? All of you know, it's a systematic way of collecting data, documenting it, analyzing it, and interpreting it. And there are different research methods. Different disciplines have formulated different methods. And yesterday you had a presentation on how to write papers and all. So different disciplines again have different formats also. Like if you're writing a paper for science or technical paper, it may be different, format may be different. If you're writing for arts college, the paper may be different. So all these things you'll understand if you write papers. Say, for example, I wrote a paper for International Journal for Gandhian Studies. Earlier, Geetam University, Visakhapatnam had a Center for Gandhian Studies. So that journal, like it used to publish around 6 or 7 papers in each issue, and very selective peer review. And the format, the format was again specified, and it was very difficult writing that paper rather than maybe a paper for engineering or a architecture journal. So different journals, they have their own formats, and broadly you can say quantitative research and quantitative and qualitative research are followed. But for the field of architecture, which would be more appropriate? This again is a bit debatable, but I would prefer the mixed method. Mixed method is a combination of both qualitative and quantitative research. Where do you use qualitative research? Where do you use quantitative research? This should be quite clear. See, if you enter into a room, for example, there are certain things which you can quantify. For example, I can, take measurements of the temperature, noise levels, the lighting levels, sound levels, all this I can quantify. Humidity I can quantify. So for this, I need the numerical data, and I have instruments. I use these instruments and I get the data. But then what would be the response of a person who enters into the room and looks at a room with a certain color combination, or the volume of the room is different? So there are certain things which you cannot measure. The response would be differing from person to person, and it would be subjective. So there you need to use your qualitative methods, and qualitative methods can help you understand the behavior of people, how they are behaving. So quantitative methods will not work there. So since architecture is a combination of art and technology, where the technical component is to be measured, we need quantitative methods, and where the art component is to be measured, we have to go in for the qualitative methods. The earliest book I read on qualitative aesthetic research is a book called The Language of Architecture by Sven Hesselgren. So after reading that book, like one can get an idea that if you go into qualitative research, it will be very, very difficult, because everyone has a different opinion, and not many people agree to the findings of a particular person. They'll say, no, this is like this is not the way I feel. So a lot of subjectivity comes in. So it becomes a bit difficult to convince people about qualitative research. Whereas quantitative research, that problem is not there. And both of them have different philosophies and views. And so now there are certain terms which have already been told to you, but I will again go because they're important. First is the research question. So what exactly is a research question? This pinpoints exactly what a researcher wants to find out in his or her work. So it is essential to guide a research paper, dissertation, or thesis. Data collection is the systematic process by which you take observations or measurements. And many times, when you're different types of research, one of the major problems is data collection. Many times, it's difficult to get data. When I was doing my PhD in IIT Roorkee, I had some colleagues who were working in water resources, and they were finding it very difficult to get data ungauged water which falls on the ground and which is not in a marked area. So how that water goes and all that. So it was very difficult to get data. And climatic data, for example, in my work, I had to collect climatic data for past at least 15 to 20 years. So getting 15 to 20 years data in India, actually, we get the data from IMD Pune, and it's not done in a very proper way. They sell the data, you need to pay for it, and then finally you may not get the complete data. Whereas in the other countries, all this is put on the net and you can directly download most of the climatic information. So there are different ways of collecting data. We'll go into that. There's another word here called operationalization. What does it mean? So see, there is certain abstract concepts which are difficult to measure. So here, like how you can talk about this concept. So which is the way of measuring these things? If, for example, there's something like social anxiety, like you can't observe it, but then you can carry out certain interviews and get some scores. How suppose someone is avoiding going to a crowded place, that means like he is afraid of crowded areas. Then say a simple example is suppose there's a person who's afraid of heights. How that fear of heights translates into what the architectural implication for an architect. So you have a man who's afraid of heights. Now, if you're designing a building for him, he'll say, I don't want to have a staircase in the building. He's afraid of going on a staircase. So then he'll ask for a lift. So that way, some of the phobias of people, they can, you can measure them by using certain ways. Another question is social capital. Yesterday, Madam was talking about social capital. Social capital is very important. And how do you judge social capital if you're doing some socioeconomic surveys? For example, what is the cohesion between people of two different communities? This can be seen in the event of a riot. For example, if there's a Hindu-Muslim riot, then you may find that some Muslim families are giving shelter to Hindu families who are being maybe attacked by the Muslim population. So what does this show? This shows that the social capital is very high. And suppose during time of disaster, if someone is drowning, if a neighbor jumps in and saves him, the social capital is high. If you say, no, I'm not bothered, then social capital is very low. So there are some ways of assessing these things. Just 1 second. So when you're trying to collect data, like how that data can be operationalized, that is another important aspect. Now, I told you what is a research question. So research question is very important. So as Krishnamurti was saying, to ask the right question is far more important than to receive the answer. The solution of a problem lies in understanding of the problem. The answer is not outside the problem, it is in the problem. This is an example. So all of you are aware of the Bauhaus. And in Bauhaus, there was a person called Marcel Breuer. So Marcel Breuer was looking after the product design branch of the Bauhaus. So Bauhaus had different workshops, like Vasily Kandinsky was looking after abstract art. Then there was a lady who was looking after the tapestries and carpets and kettles. And then Marcel Breuer, there was another person who was looking after photography. I forgot his name, but Marcel Breuer was looking after the product design. And one of the most famous chairs that he designed is known as the Vasily chair. And so if you look at the chair and the solution, from the solution you can get the question also. Say, for example, Marcel Breuer's solution to the problem of creating beautiful, comfortable, functional seating with minimal materials and at minimal expense. So the research question of Marcel Breuer can be summarized as: how can one create beautiful, comfortable, functional seating with minimal materials and minimal expense? If that is your question, then the answer is before you. This is how he answered his research question. So what is research question? So you should have a very strong research question. If the question is strong, how will you know whether the question is appropriate? The measure of the strength of your research question comes from the response or outcome. Like you asked a question which is very appropriate. If you get a very strong answer, you get a very good answer, that shows that the question is very strong. But if there is, very vague answer, you don't get anything, then that means the question you ask is not very strong. I'll give a small example. We had a cyclone in Visakhapatnam in 2014 called Hudud. So there was one question which I asked that time. A lot of trees were damaged in our campus in Geetham, and a lot of trees were damaged in Visakhapatnam. And since I was teaching a subject called landscape architecture, I tried to find out, the question asked, how are trees damaged during a cyclone? Well, the first time, I started studying how trees are getting damaged. And I found there is very little literature. Very little literature. I could just get some idea, the different ways. And some ways we couldn't figure out. For example, in Vizag, the trees, the leaves of all the trees became black. And why it was happening, we tried to find out. Nobody was getting the answer. They thought the trees are dead. Went to the botany department, then read some papers and all. Then finally it was clear that it's because of the deposition of salt spray on the leaves of the trees. So now we started studying that. How far will the salt spray go? So almost up to 50 kilometers, the salt spray was going. And if the trees are washed or sprayed with water, or if there's a rain after the cyclone, then the salt spray gets removed and the tree might survive. That was one of the ways that trees were getting affected. Other ways were, they were breaking. So now when their branches were breaking, what type of tree, how the damage occurs. And then there are some research papers you could get about, they did some tree pulling tests. And from that, we could gather, okay, one of the ways of damage is by, breakage of the stems. Third one was, the leaves are falling, some of the trees. That is called defoliation. So how the leaves fall and what happens, how much time they take to again come back. So all these things we started studying actually. And because it was a very, finally what happened, this question resulted in very good papers, almost 6 or 7 papers. One paper in Wind Engineering Society, another one, because there, people study only on buildings. Nobody studied about how trees are breaking because of the wind. Then, this Arindam Biswas was the earlier speaker. He was the editor of this book. And it was published as a book chapter by Springer. And then this studies also led to vulnerability assessment and restoration. Again, after the trees are damaged, how they were restored. In Geetam University, lot of trees which got uprooted, which were given up for dead, they were again restored. So first is, before the cyclone, after the cyclone, then restoration. So all these stages were studied and then compiled, and that resulted in papers in the Fourth World Congress on Disaster Management. All over the world, people are interested how to restore trees which are damaged in cyclones. So, and the paper in Turkey, for example, had 1,000 downloads. So of course they don't consider download as a, that is not part of the criteria for good paper. We talk about other index, this index, that index. But my question was, why will people download? Why will 1,000 people download a paper? Because they're interested. People are interested in knowing something, then only they'll download a paper. Nobody is interested in downloading some paper in which they're not interested. Anyway, so these are some of these things. And this is talking about the research question. Now, this is a little out of the way, maybe you may think, but it's important. What are the qualities, important qualities for a researcher? See, suppose most of the people who are attending this FDP, many of them, I think, are teachers, faculty. So one question I normally ask when we do an interview for faculty is, what is the most important quality for a teacher? So someone says he should be a good researcher, then he should do research and he should do this, he should do that. But then I don't know how many of you will agree that the most important quality for a teacher is empathy. He should be able to put himself in the shoes of the student. He may be a very good researcher, but he may be a very bad teacher if he doesn't have this quality of empathy. So just like important qualities for a teacher, there are 3 important qualities for a researcher. So what are these qualities? One is curiosity. See, you must be curious, like why this is. So, as a child, as children, we are very curious, That time we are not afraid of asking questions, Like sometimes parents will say, asking questions when they don't know the answer, or don't ask some stupid question. But then the more you ask, the better you might get the reply. So you should be curious why this is happening. And that curiosity is important, being able to ask the right research question. And then persistence. See, many times what happens is like when you're doing research, like you may not get the correct data, you may not get the answer, or something might happen which might interfere with your research. See, I'll give us a very good example. One of my colleagues in Geetam University, Visakhapatnam, called Ravindra, good researcher, doing very good work. Suddenly his guide died. Now that's something you don't expect when you're doing your PhD, that your guide is going to die. But then that became a setback. Like it might have increased the time for his research. So, but then some things can happen which might deter you. Their persistence comes in. Like you have to be persistent. And third thing, this is important, ability to visualize. See, if you are able to visualize like how your work is going on, or what you want to do and how things might turn out, if you can picture that in your mind, then that will help in converting and abstract ideas and models into tangible outcomes. See, today in front of you, you see so many things. You see a cell phone, you see a laptop, you see a mouse, or you see a pen, or you see a cup, anything in your room. Just look at your room, look at any object. How did it come? How did it manifest? It manifested first as a thought. Somebody must have thought about it. If you see your laptop, laptop did not fall from the sky. Somebody thought about it, like somebody visualized how this can be created, and finally it got physical form. First, it was born as a thought in somebody's mind. And if you're able to visualize something, then that picture, if you can hold that picture in your mind, that picture will become physical and it will manifest. This is, like something which is important. So visualization allows us to think in a non-verbal way. So when you are thinking in pictures, you can think about things which are not yet seen. So when you're talking of research, how your research might go, if you're able to visualize, then many times, it can happen. And I use this tool, like very strongly. Like there were times when there was no other solution. Maybe the research had to be terminated or closed. Then I started visualizing. And then whatever I could visualize, that happened. And it's a way of unlocking the right side or the creative part of your brain. See, this, I'm giving a small example. See, like while I was doing my research in IIT Roorkee, I found that the wind tunnel in IIT Roorkee does not have the technique which I wanted to use. It's a boundary layer wind tunnel, but when I started doing my research, initially I wanted to work in the boundary layer wind tunnel in IIT Roorkee, but then midway my objectives changed. Sometimes your objectives might change. And when my objectives changed, I realized that I cannot use the wind tunnel in IIT Roorkee because I wanted to test the effect of wind at pedestrian level, the impact on pedestrians, because as an architect, I'm more interested in people and their activities. But then I found this wind tunnel is not having the things that I wanted to measure. Then I started finding out where in the world do we have this type of research is being carried out. So I zeroed down in three places. One is MIT, where you have the tunnel, and second was University of Auckland, New Zealand. The third was another place. So then I downloaded the photographs of these three places, and on the left-hand side picture is that of that's the city of Auckland. The tall building is the, like Auckland Tower, Sky Tower. And the picture is taken from a small island called Devonport. And so I downloaded that and pinned it in my board. And then I started visualizing that I'm standing on that island. And then I forgot about it. And after 2 months, I went there, went to Auckland. I got selected for a collaborative research project by the University of Auckland and IIT Roorkee. And then visited that place. And then there was a point where people take photographs. So I got a photograph taken there. So when I came back and developed that photograph, I found it's the same spot which I had downloaded from the net. So the left one is from the internet, and the right one is what happened. So, like this technique I started using for other things. Like I wanted to go to see the Hagia Saint Sophia Byzantine Mosque. So I put the picture of that, and then I'm standing in front, and that also happened. So tomorrow you want some things to happen. If you can picture that in your mind, you see that picture will have to become a physical reality. This is called creative visualization, and it's very important in research. Okay, next, data collection. This is a very critical step, and you need to find what is the data, because you have too much of data today. Like for everything, there's so much of data, so you need to remove data and use only data which is useful for you. There are so many methods, so many techniques. If you see statistical techniques, there are hundreds of techniques. And when you're studying research methodology, study all these methods, but actually the technique or method which you want to use not have been taught in research methodology. Then what do you do? So you need to select the appropriate tool for your research. In my case, I had to use type of distribution, statistical distribution called Weibull distribution. So I went around IIT Roorkee asking people, come on, tell me about Weibull distribution. Nobody could tell. So nobody had used it actually. But then how did I know that I have Weibull distribution? That is because I had downloaded papers, a lot of papers related to my field. And the journals where the, people related to architectural aerodynamics, they were all using Weibull distribution. So then I realized there is a reason why people are using that distribution. And then later on, I could find out the answer only after going to Auckland, that Weibull distribution is a method used in reliability engineering and wind engineering. Suppose you're designing a wind turbine or you're doing wind tunnel studies on tall buildings, you have to use the Weibull distribution because the wind, the maximum, the things which you are measuring are the way it is occurring, the median is very powerful in wind data. So Weibull distribution, the median, more stress is on the median. So that is the distribution which they were using it. Not a bell curve or any other. Okay. Now see, there are three types. I told you: quantitative, mixed, and qualitative. So very quickly we'll see quantitative number-based, and many times because it's number-based, it can be manipulated. You can also, give some wrong numbers, and unless those numbers are verified, validated, did that or not, you can fool people with numbers. Now, qualitative is behavior-based. This is a bit more difficult, and mixed with a combination of qualitative and quantitative data collection methods. Now, this quantitative involves measuring and counting, and whereas qualitative involves interviews and observation. You need more time for planning quantitative method, but less time is required for qualitative. In the qualitative thing, you need to be specific, like you're maybe doing it for a particular group, you're studying them separately, whereas here you may be talking about numbers, and a lot of subjectivity may come in a qualitative research, but the quantitative, and in mix you can use both the methods. And how do you collect data in quantitative method? From surveys. So sometimes you have this structured survey. Now, structured survey, the questionnaire is prepared and that is administered to a lot of people, and you get the answers. Many times, this type of structured surveys, the answers are quite biased. So there are a lot of failures in tourist-related planning developmental projects, where they found that the projects are failing, and people are not behaving the way they expected them to behave. And that gave rise to the participatory approach and the bottoms-up approach. The top-down approach or the blueprint approach, where you say, I'm the architect, I'm the planner, I'm administering a survey, you give me the data, you tell me what you want. Those things they found are not working. And today the architect has to use the bottoms-up approach, where he goes and he becomes a facilitator. He becomes part of the people for whom he's designing. And like sometimes, they even stay with them. And then the data and the answers, they encourage them to come out with the solutions also, not just the. So the people also, they take part in the entire design process. See, this map you might have seen in a movie called Swadesh, where Shah Rukh Khan goes to the village and he uses this bottoms-up approach. And you can get data from case studies and interviews and ethnography. We'll discuss what is ethnography. So now, suppose you're the final product. Example, if you're using the quantitative methods, how will you describe the yield of the final product after? Suppose you're taking out some product, extracting some product. Then if you have to describe it through quantitative research, you will say the yield of the final product, the extraction was 78%. So how much of the product were you able to take out? But if you're doing it in a qualitative way, you'll say the product after extraction was a white powder. talking about the quality of the powder. You're not talking about the quantity. But in the mixed one, you're saying the final product after extraction was observed to be a white powder and the yield of the product was 78%. So here you can see that the mixed method is more powerful. You are getting the best of both the methods. And we can quickly go through this, skip this. Like I told you, it's an objective analysis and qualitative research, you have subjective. See, what happens when both get mixed up? Simple example of a mix-up is yesterday I had a powerful session with Professor Konda Ramesh. Now, he has done a lot of work on thermal comfort and where the major problem in thermal comfort comes. Thermal comfort, it's very easy to measure the temperature, easy to measure the humidity, it's very easy to measure the quantity of dust which is there. And you can say that, okay, the indoor air is good, this, that. And the major problem comes with the subjective variables. Because when you're talking of comfort, to talk about the type of dress people are wearing, which is highly subjective. You need to talk about the color of the skin. You need to talk about the age of people. You need to talk about the sex, whether the male or female, color of the eyes, so many things. And what type of food a person ate before into the room, how comfortable he feel, what type of activity was he performing, was he sleeping or was he playing some game? So all these are going to affect how a person is responding to an air-conditioned environment. That is very, very difficult, the subjective variables. Quantitative variables, you can easily find out. And okay, so these things already, they have been explained by the other researchers. So I'll quickly go through this. And yesterday they were telling you about inductive and deductive approach. And what are the methods used? Like in quantitative, basically you'll be using experimental or quasi and probabilistic sampling. And like in qualitative, you'll be using words, images, and there's a lot of personal involvement in a qualitative study. Whereas in a quantitative study, you're talking of numbers. You're not concerned with, feelings and, behavior and these type of things. See, here there's another, in mixed method, what happens is the approach helps the researcher to, there's a word here, you need to find out what it is, triangulate. What is the meaning of triangulation? To back up one set of findings from one method of data collection underpinned by one methodology with another very different method underpinned by another methodology. So when you are mixing both, then you need to triangulate. See, example, you might have a questionnaire which is normally quantitative to gather statistical data about responses. And after you get all the responses, you can back up your research in more depth by interviewing. Interview is a qualitative one. So you can, like have a, like focus group interviews, or you can have, questionnaire through interviews, so telephone calls. So both these things, it's a mixed method. Now, this word ethnography, what happens is, it's a study through direct observation of users in the natural environment rather than in a lab. So, all different from how they may behave when, they know that they are under observation. Say, suppose you may behave differently in your house, but then when some guest comes, you may behave in a different way. You're trying to project yourself as a very, calm person. But when there are no guests, then you may be shouting at your wife. So, so what happens is, when you do ethnography studies, you can see how people are actually behaving in a setting, and that will help you in taking certain design decisions. A simple example is, I want to know whether people are interested in using the elevator or a staircase. Now, I want people to use staircase rather than the lift, because that might help them and getting some physical exercise. Now, how do I make them use that staircase rather than the lift? So there are some examples where, like on the steps, they have made, in some cities, they have made these steps just like the keys of a piano. And when you're moving on that step, then the sound comes, musical note will come. Now that has made people get interested, and they're more interested in using the steps because of the music that is coming out as they step on the staircase than on the escalator or lift. Usage of the staircase increase because of that. So these type of studies can help in getting better design solutions. Okay, now we come down to we're going now towards the experimental part. What I've told is the general things about research. So now tall building aerodynamics. So what is aerodynamics? Aerodynamics is air that is moving. And, like when air is moving and it encounters a tall building, then what happens? So tall building aerodynamics is concerned with the impact of wind on tall buildings. And air, you cannot see wind, but then you can feel it. You can feel wind on your face. But then again, you want to know exactly how wind is behaving. You can do that through wind tunnel experiments. So experiments are conducted in the wind tunnel, and where you want to visualize or actually see what is happening, you can use smoke in the wind tunnel. So here in this picture, you can see there's a tall building, and in front of that, there's a low-rise building. So this is a model, maybe in 1:400 scale, and it was done in the British Research Establishment wind tunnel in London. So here, what a researcher called Wise, what he did, he and Penwarden, another researcher, they observed the impact of wind with a small building in front of a tall building. So they found that the wind at around 2/3 of the height of the tall building separates into one component which goes above the building, another component which goes from the sides, and the third component comes down. It's called downwash. And this component, what happens? The wind velocity increases with height. So let's say at a height of 50 stories, the wind velocity is 15 meters per second. So that elevated high velocity wind is now forced towards pedestrian level. And if there's another shorter building in front, then behind that short building, again, you have an eddy formation or a negative pressure zone. And this negative pressure combines with the downwash, and that accelerates or amplifies the wind velocity at pedestrian level. And this can cause problems to people who are using these tall buildings. And suppose there's an entrance in front of the tall building, then it may be difficult for you to open the door, so there are a lot of problems which can occur because of this downwash. You can't see the downwash, but then you can measure it by some ways. So this is, so what happens by carrying out these experiments in the wind tunnel, the researchers are able to come up with certain theories, say, for example, they came up with how wind behaves in such a case. So what are the different types of wind flows? So these wind flows, again, 3 types were identified. One is called vortex flow that develops near the ground. Vortex means something that is rotating. You can see the picture here, the vortices. Then descending airflows around windward corners. So the corners of a tall building, this is where, it's a bit, the wind speed will be high at the corners of the buildings. So as an architect, how does it, what can you imply from that? Like when you're designing a very tall building, it's better to avoid the balconies in the corners. Because, if a person goes and stands there, you take a 100-story building and a person standing in the balcony there, he might be sucked out from the balcony. So it's better to keep the balconies in the middle and not in the corners. and airflow through ground floor openings connecting windward and leeward side of a building. That is, front and back of the building, there will be short circuiting of air, and that can increase the velocity of the air which is passing through the building. So these are some theories which were developed about airflow around tall buildings. Now here you can see how the wind can affect people or pedestrians. If the wind speed increases more than 11 to 12 meters per second, then umbrellas will get upturned. They have difficulty in operating the umbrella, and papers get blown off. See here, this is an interesting example where there's a bus stand in front of a very tall building in Toronto. So there, people, they normally they were experiencing difficulty in standing. Some of them are falling. So the people form a human chain and hold on to the bus post there to prevent from falling. So like when the wind speed increases beyond 11 meters per second or something like that, then people have difficulty in walking. And if it goes beyond 15 meters per second, a person will get lifted off and fall down. Like the last picture shows old lady in Boston, how she was lifted off her feet and fell on the road in front of a tall building. So what happens here is because of some accidents which were caused because of wind and in the vicinity of apartment buildings, 16-storied apartment buildings, a lot of interest started getting created for carrying research in the impact of wind in the vicinity of tall buildings. Now here, let me tell you one small, what might happen if, there's a lot of interest in doing a type of research, and a number of tools are developed. Softwares, you have this software, that software, and someone comes and says, I use this software, I can do this. I use that software, I can find that light level, I use this. Now the problem is, you may get carried away with these softwares, but finally what happens is data you get may not be the correct data. So you have to be careful about selecting the right type of software. Now, initially what happened, architects were interested in how buildings, impact of wind on buildings, So architectural aerodynamics started getting some interest, and in many colleges, this was started as a postgraduate subject. I started this in Philu Modi as a postgraduate subject when I was there, So here what happened, initially, architects got friendly with aerodynamic engineers, that is aeronautic engineers. And they started giving their models to the engineers for testing. These aeronautic engineers were happy to please the architects. So they took their models and they started testing them and giving them the results. But what happened was the actual thing that may happen, the real-time situation was totally opposite that of the results that were obtained from the wind tunnel test done by engineers. That was because, they had overlooked one very important component, and that is, the obstruction to the wind, which is caused by different obstacles on the ground, like trees, it could be buildings, it could be, any other obstruction. So that's on the wind. The aeronautic engineers, the aeroplane is not moving on the ground, it's moving above 500 meters at gradient height. Gradient height is above 500 meters. So there they don't have these obstructions. So they were testing their buildings in a type of wind tunnel called laminar flow wind tunnel. And they started using testing architects' models also in these laminar wind tunnels and giving wrong data. So then what happened, this fact was noticed, and then finally one researcher called Jensen, he laid down certain rules that the research which is being done by architects using a laminar wind flow tunnel should be stopped, and any research on buildings has to be done, cannot be done in a laminar flow wind tunnel, which is used for testing aeroplanes, but it should be done in a boundary layer wind tunnel with appropriate obstructions for creating the required velocity and turbulence. So turbulence is like the wind will become random when there are some obstructions. Like if you observe the smoke coming out from a cigarette, it might be laminar, but little bit of wind or something, then the entire smoke starts moving this side, that side. So the motion becomes totally random. So if you want to study the effect of wind on buildings, the testing has to be done only in a boundary layer wind tunnel, not in a laminar flow wind tunnel. So once this rule was laid down, this testing by the aeronautic engineers stopped, and wind tunnels were designed with the required, where the simulation of the wind was done in a correct manner. See, this is like I told you, by doing some experiments in wind tunnels, the three effects which they came up with. So these are some models which were tested in the Auckland University wind tunnel. And there, between blocks, this how wind can speed up through passages. There's something called Venturi effect. And then if there's an opening between buildings, how it can speed up. So all these things can actually be studied in the wind tunnel. Then you have something called wind climate analysis. So here again, like I told you, you need to get data which is there for at least 30 years, because once you collect all this data, then you need to see what is the reason for getting data from Delhi. The thing is, like, the wind tunnel testing which was done was in Auckland, but then the wind simulation is done for the wind directions in Auckland. So if you want to see the effect of that in a neighborhood in Delhi, then you need to use the data from Delhi. So that is the reason that this particular climatic data has to be taken, and that has combined with the wind tunnel data, and then using some statistical distribution like Babel distribution and imaging system, the entire pictures come out. So that the wind data that you get, like you have to convert that yearly data, and then that yearly data for different directions. Like, because you're going to test your buildings for, different sectors. Wind can come from anywhere. So the prevalence of a high velocity winds are coming from which direction can be seen from these type of you analyze the data in this way, and then you create certain probability exceedance graphs for each direction. And say, for example, in the right one, putting it in the Weibull distribution, you can know that a wind speed of let's say 8 meters per second, or say 5 meters per second can occur 10% of the time. So like probability of exceedance, how many days the wind speed can exceed that for different directions can be got from the wind studies. Okay, we'll go into that detail, but now let's come down to what is an experiment. So experiment is a procedure carried out. So you have a hypothesis, you're either supporting it or you're refuting it. And something that was not done before, you're trying to find the likelihood. See, I'll give a small example. A lot of work is being done in an area called nanotechnology. So in nanotechnology, one product was developed recently by Pantaloon, Pantaloon shirt company, clothes company. So they came up with a nano shirt. So what happens in this nano shirt? If somebody throws a cup of coffee on your shirt, the coffee will not stick to the shirt. So you don't have to wash the shirt. So the same thing is being done for tiles, like dirt won't stick to tiles. Then you have nano glass, where nano glass, you pass around 7 to 8 10% current through the glass, and the glass becomes opaque. So this is a nano glass. So a lot of lot of experiments have been done on different products using nanotechnology. But the problem is that the environmental effect of these products is not fully tested. So, you may be using a nano shirt, very happy to use a Pantaloon nano shirt. I use it for 5 years. And then, later on, I find that it had some impact on the health of a person who was wearing it. So unless the, those tests are done, where the environmental impact of these materials that is not fully known, it is difficult to use these products. But then they are changing using your different spaces, say carbon nanotubes. For example, carbon nanotubes are going to replace steel, and then they would the spacing between columns. All this, the way you design buildings is going to change because of nanotechnology. Okay, so in future, the color of your room, for example, cream color in my room in the daytime, then in the evening it becomes green color. So the color changes. So like that, research is being done in nanomaterials, nano paints, all these things. And IIT Delhi, they have come up with nano glass windows. So many of these experiments are required to come up with these type of products. And okay. So what do you do in experimental research? It's based on observation, calculation, comparison, and logic. You collect data, you perform statistics. Another thing is the environment is done in a controlled environment. Yesterday we were discussing, Dr. Mishra was asking that question. It's a very important question. See, what happens is, like, most of the experiments are done in a controlled environment, and you're controlling many of your variables. So what happens when you control that variable? That variable may be the actual one which has an effect on the outcome. So the result you get may not be very correct. Simple example is like doing wind tunnel testing is very expensive. One wind tunnel test will cost $2,000. So what happens is people have come up with CFD, computational fluid dynamics. And it's an alternate way of doing the calculations. And so computational fluid dynamics has become quite popular. Now what happened is people started using it very, very in a very big way. And then they started claiming that CFD results are very accurate. But then now they are, many of the top research institutes, they are saying that CFD can be used as a tool, but it cannot be, the results can be taken as fit for research. Because, like some of the boundary conditions, may not be very, very clear. Because the term in computer digital, they say garbage in, garbage out. So if you give the wrong boundary condition, then the entire result will be wrong. So when compared to this approach, like this controlling the manipulation of some of the text, what happens, there's some little twist in the equation and the whole result goes out. Because in CFD, what's happening, they're solving something called Navier-Stokes equation, which has around 7 variables. And, solving that takes a lot of time. And you have to solve that equation for every point in the room. If you are using CFD, then they make a mesh, and at every node, that equation has to be solved by the software. You're using Gambit interface and CFD software. So mechanical job, just you're solving that equation 100,000 times and then getting all the points, connecting them, and then you're getting a picture of wind flow either through the building or above the building and all. But one small mistake, can give you exactly opposite result. Tool, it has its own limitations. You can say, simple example is, suppose you want to study the effect of wind on the wing of an aircraft. You don't have to bring the whole aeroplane. You can actually perform CFD analysis and get the wing tested and repaired and things like that. But for wide research, CFD is still in infancy, you can say. Now, most of the experimental work you can see in medical research, like you develop medicines and vaccines and all that. Another thing is software development. All of you may be aware that, like before you release a software, then you come up with a beta version where you can open it to public and they can use it for some time. And then they may find some problem with that. And then they again give you feedback and they say that, okay, you need to correct this, you need to correct that. So that is one way that computer companies, they release this software, and through experiments again they can improve it. So the scientific method has certain disadvantages. One is human error, because you're controlling certain variables which might nullify the validity of research. And the real life scenarios, because see, if you're trying to see the temperature, the heat that passes through the wall, then in laboratory conditions we are taking a heat source and that is kept constant. And you see how much temperature is coming from one outside to inside. But what happens in the actual scenario, real life scenario, is that the heat flow is periodic. As the temperature, the heat comes inside. By the time it comes inside through a thick wall, which has 4 or 5 hours time lag, then the outside temperature falls. So the heat flow gets reversed. In laboratory testing, this is not taken into consideration. We are taking it as a constant heat source. So this periodicity is not taken into account. Another thing is there could be human error. For example, when we were doing this wind tunnel testing earlier, an image processing system was not developed in the University of Auckland. And the researchers would be standing next to outside the wind tunnel and looking through the glass enclosure at the erosion which was occurring inside the wind tunnel of the particles which were getting eroded. There's a total room for human error. But when later on a charge-coupled camera was fixed to the top of the tunnel and it took photographs using an image processing system, then the accuracy increased by 95%. So that is one of the problems with this result. Okay. See, I'll give you some more simple examples of experimental research. Earlier, I was teaching in Pilumudi College of Architecture in Cuttack. So that time I had a chance to do the landscaping for the building. So here you can see there's a creeper called Pyrostragia venosta, or golden shower. So that was covering the front facade of the architecture building. And then later on, I took this picture with a thermal imaging camera. Now with the thermal imaging camera, if you compare the, you see the area where the creeper is, the temperature there is, less. You can see from here it is around between 15 to 25 or 26. But the area where there's no creeper, it is around 30 to 35. So almost around 4 to 5 degrees Celsius drop is there. The heat is reduced because of this Pyrostragia venosta creeper. Okay, so similarly, we did thermal imaging for this Tecoma Gaudi Chaudi tree, and the shade cast by that tree, that area, the temperature is less. Similarly, we did on the buildings also. So this thermal imaging camera, it's a very good tool which has been used by students in Gitam University, and we also did. We tested the urban heat island effect, or the landscaping as the countermeasure for reducing the urban heat island effect in the campus roads. So temperatures were taken during the different times when there was no shade on the road, and then when there was shade on the road. And from that, the effectiveness of the vegetation in reducing the urban heat island effect was found. It was presented as a paper in international conference on IIIT, Hyderabad. And so these are some examples of how you can use some instrumentation for getting some results. Now there's another example of shake table. So shake table is a very powerful instrument which is used in earthquake design. So what you do is you make a model of building or any buildings and put it on the shake table, and that shake table vibrates, and so as that will vibrate, building will start vibrating, and then you can see whether the building is getting damaged and what would be the type of damage, how the walls are breaking. So in IIT Roorkee, you have this shake table, and these are used extensively in seismic research. And today, the major development in the shake tables is that all the seismic accelerations, the ground accelerations have been recorded. So there's a software which gives all the different types of earthquakes, and so you can put your building, and then you can test it for Bhuj earthquake, you can test it for La Preta earthquake, you can test it for Northridge earthquake, Mexico earthquake. So which earthquake you want to simulate? You tell the name, and we can tell you whether your building will withstand this effect, Kashmir earthquake or not. So that can help in taking certain precautions. So that is for earthquake. Now, come down to my area. This is in engineering, wind tunnel. These are the early days of wind engineering. So here you can see on the left-hand side, Davenport. Davenport was the father of wind engineering from University of Toronto in Canada. So he has tested the majority of the tall buildings in the world. He passed away. But in front of him, you see there's a Japanese architect called Minoru Yamasaki. So Minoru Yamasaki designed the World Trade Center. And that was the first building, tall building, which was wind tunnel tested. And when they tested it, they found that the building is swaying by almost 1 meter. That means, someone's sitting in the topmost floor of the Twin Towers, he would be moving, the furniture would be moving, and the building would be swaying. So this would give rise to a lot of nausea to the people who are living in that building or working in that building. So since this could be ascertained by testing, later on they used the elastomer dampers in the see this World Trade Center, it used a truss. Some of the participants who studied tall buildings in Gitam know that the trusses were one special type of structural system was used. And that structural system had columns in the exterior and a truss connecting to the core in the center. So this truss had elastomer dampers. These elastomer dampers would reduce the sway of the building. And that is what caught fire actually. When Osama bin Laden's aeroplane hit it, then those trusses caught fire, and that's how the World Trade Center collapsed. But this is the first wind tunnel test which brought wind tunnel testing to the notice of the architectural community, and many of the tall buildings started getting wind tunnel tested. Now, one important review for any researcher, if you're doing PhD, is there's a viva which you need to give, and that is known as a state-of-the-art viva or state-of-the-art review. So here, this was the state-of-the-art techniques for measuring pedestrian winds, because I was using certain instrumentation for measuring the winds in the vicinity of tall buildings. I had to find out what are all the available instrumentation or techniques which are used around the world. So I had to compile all that and then explain that in a review. So in IIT Kanpur, for example, we have laser Doppler anemometer. Then you have a hot wire and hot film. That is the most simple instrument, but many times you have to replace that wire because it breaks. The third one, you can see the balcony of the Burj Khalifa. And this is the model of the Burj Khalifa. Okay. So the Burj Khalifa, you can see it uses something called Irwin probes. So these probes are placed in the balcony, and the wind velocity could be measured at that point. Then there are some other instruments like Cobra probe, which is a much more developed version, require anemometer, then the particle image velocimetry. And the last one is a technique which I use. This is called the erosion technique. So this is the bran is poured on top of a model, and the model is put in a wind tunnel, and the speed at which the bran lifts off, that is measured. So anyway, now this is a Cobra probe. So on the left, so this is the wind tunnel in the University of Auckland. The Cobra probe is an instrument which can, there is a robotic arm which moves along the wind tunnel, and the probe is fixed to that. It can be lowered down to the point in the model where you want, and then the measurements can be taken. So I took some measurements with the Cobra probe, but the problem is you can get measurements only at certain points in your entire neighborhood, and it's very time consuming. So the technique which I used, the entire neighborhood, at one time you can get the areas where the wind speed is more or less. Now, the one method which our earlier speaker, Shivaji Garu, he was talking about case study method. Now, case studies are important because they can help you. In my case, I carried out case studies on tall buildings because I wanted to find the potential for adverse wind effects in tall buildings. And some of it were the Trident Hotel in Mumbai, 35 building in Nariman Point. Most of the cricketers, they stay there. So here there is a swimming pool at the base of the tall building, which is a very wrong architectural blunder, you can say, because what happens is that downwash from the top of the building, it comes down and the wind velocity increases in the swimming pool area. That is the area where people would be, swimming, or they would be sleeping on those chairs with the minimal clothing, and they would get wind chill if the strong winds are blowing over them. But then once you have designed that swimming pool in the wrong location, you can't remove it. So I went to that swimming pool, I took some measurements, and this is one case study. Another case study is, these are, like I told you, this Wise effect in the wind tunnel, that has been become like a rule. It has become like a law, So that law, whether it is visible, there is a potential for Wise effect here. This is a Nehru Place, where there's a tall building with a short building in front. So the area in between would be very windy because of this Wise effect. Then, there's some apartments in Mumbai called Living Point Apartments in a place called Bhandup. So there, this gap effect, there's the potential for gap effect, because you have one opening in the front and there's another opening behind. If you want to reduce this gap effect, all you have to do is close one of the openings. Then there would not be any short circuiting through the building. Then again, there are some apartments in Delhi, in Dwarka, where a lot of Venturi effect is seen, like because of the tunnel effect. Then we studied some apartments in Ghaziabad. There's a place called Indirapuram. So here you can see that a lot of windows, balconies are there in the corners. And this is one such balcony which got damaged because of the wind. This was on the 8th floor. Then we did some experiments in the Vadala. You might have heard of Vadala. This is in the outskirts of Mumbai. So here there's an apartment called Himalayan Heights, and this gentleman is one of my students who is working in Bombay Metro. So he helped me in collecting this data. So if you are sitting in the, like in front of this tall building, it becomes difficult to read a paper also because of the wind. Then we took measurements at the corners of the buildings where the wind was amplified. Now I'll just quickly show you a collaborative research project which was done between IIT Roorkee in the Center of Excellence in Disaster Mitigation and Management and University of Auckland in New Zealand. The left-hand side, you can see that's a open circuit wind tunnel in IIT Roorkee. Open circuit means you have just like a single tunnel, and one side you have the turntable with the model, and the other side you have the turbine which blows the wind. And the testing was being done for signature towers, like in 2009. So that time, in Calcutta, this I think Mukul Mitra architect, he had designed this building, and it was given to IIT Roorkee for the wind tunnel testing. So the building which is wind tunnel tested, you can see in blue and red color, that is painted in a different color to set it apart from the other buildings which are acting as the surrounding buildings. Anyway, right-hand side is the boundary layer wind tunnel, which is a closed circuit wind tunnel in the University of Auckland. And, it was designed by one very famous researcher called Richard Flake. And here on one side, racing cars are tested. And on the other side, with a low speed section, the buildings are tested. Racing car, you need high velocity wind. So this is a closed circuit tunnel. You can see the turntable on which the model is placed, and there are like I can show you see, this is the interior of the tunnel. So you have the turntable, and there are a lot of blocks. These blocks will slow down the wind and cause the turbulence. So you have graphs, and you have to simulate these things. These are measurements taken inside the tunnel, which should coincide with the graphs which are given, velocity and turbulent intensity profiles, which are given in the code. If that is not coinciding, that means your simulation is wrong. And if your simulation is wrong, then the results are not accepted by the international community. So before you start your experiment, you have to do the correct simulation, and you have to, because these things are given the terrain for different terrain categories. Suppose I'm testing a building in Hong Kong. There is only one terrain category. They're all tall buildings, so the wind speed is much less there. But if you're testing in India, for example, you have 3 terrain categories. So you have to, first of all, simulate the velocity profile and turbulent intensity profile. If that is not done correctly, then your whole experiment will be wrong. Okay, these are techniques which I used. I think my time is getting over, so I'll switch off fast. Okay, so here what happens is we put a material on top of the model, and wind from the wind patterns, and by studying the erosion patterns, just like you're studying the X-ray of a person with maybe a bone is broken, the doctor can see the X-ray and tell whether there's a fracture or not. So like that, very high there, or there is stagnant wind. Stagnant also is a problem. When there's no wind, then pollutants can get collected there, or or even exhaust fumes can won't get dispersed if the wind speed is less than the minimum. So all this information you can get. Now this is the model before making the model for a cluster of tall buildings. Then that whole model had to be painted black. The reason for painting it black is the erodible material, there had to be maximum contrast between the material and the building walls. And they finally found that when you make the model black, that gives the maximum contrast for the image processing system to get the contrast. These are parametric tests for by increasing the height of one tall building and keeping the entire model as it is, you can study the effect of wind on 54-meter high building, then 82 meters, 106 meters. So went on increasing and finally got results. This is the interior of the tunnel, and you have the model, and there's so many other instrumentation you have to, like there's a pitot tube, which is used for taking the measurement of the temperatures, pressures at different heights. So another thing is when making the model, the time when I went to Auckland, the architects were all international architects who were designing buildings. For example, Ambani's building was designed by Wilson Perkins. Calson architects were designing a lot of buildings in Delhi, and Zaha Hadid was designing buildings. So all these buildings, they started using a lot of organic shapes and peculiar forms. So the normal procedure, the engineers will just take rectangular blocks. But then I started experimenting with different shapes also. And so the model making skill, which we learned in first year BR, that helped in, at least making this model. So this is the model made of styrofoam, and the brand, once the erosion patterns are noted, then for the new experiment, again the whole brand has to be removed, and again it has to be stored in a bottle, and the entire wind tunnel has to be cleaned with a vacuum cleaner. So because if any of the brand gets removed there, left there, then the next person who's going to get the testing done is a commercial testing who pays $3,000. So they would not allow this type of thing to happen. So you have to clean the entire wind tunnel. So that gives a lot of exercise to the researcher. And there's a bottle to store the brand. See, this is the model, and suppose you're studying porticos, which are fixed to the building, then you need to make them with acrylic sheet, because the camera has to take the photograph of the erosion patterns, and it has to be transparent. Then this is the output that you get. For left side is a monochromatic bitmap image, and the right hand side is with false colors. False colors are not the actual color, but you are giving some color. Like in GIS, those who are using GIS know that red color may be symbolizing vegetation, so on. So the different color patterns indicate different wind velocities. But the problem with the image processing system was that it was not giving quantitative value to the contours. So finally, what I did was I made one discomfort parameter and erosion map key. So this quantified the erosion curves. And today that software is, you can say, strengthened because of the erosion map key. It was not there before. That time we had to just memorize, okay, this color means high speed, that color means this thing. But now you have a legend for the different curves. So this was one contribution to the existing software which was being used there. So these are experiments for showing the, like speed up at different angles, different orientation. You can see like for 60 degrees or 30 degrees, and which one would be better. Then the effect of a podium on tall buildings. Like if you add a podium, then how it reduces the wind at pedestrian level. This was one set of experiments which were done. And these are the erosion patterns. And so when you're doing anything in disaster management, for example, with and without that mitigation measure. So if you have both, then you can compare. So what are the erosion patterns with the podium and without the podium? Then tested the effect of a void in a tall building. Suppose you have a void, then that reduces the velocity of the wake. Wake is the area behind the tall building. So the velocity of the negative pressure gets reduced because of the wake, because of the void. Then then I tested the test with landscaping. So how landscaping can reduce the effect of wind horizontal winds next to tall buildings. So effect of landscaping and fences. Fences will divert the wind. They won't stop the wind, but they will divert the wind to unwanted areas. So this is the bitmap image, and this is the actual photograph in the model. So making these trees was a very difficult job because the trees should not cast shadows on the floor of the wind tunnel because the camera would, get confused. So now this is, this is a wind tunnel map which is submitted to the municipal corporation for getting approval. For example, the entire neighborhood is divided into different categories, category A, B, C, D, E, F, which are giving different wind speeds. So now the blue category, you can see here, there's a blue patch. So that means it's dangerous. The wind speed, someone might fall if they're turning this corner. The accepted category would be white and green. And if any area comes under yellow color, then that particular thing will not be allowed to be constructed. So this is the comfort category maps which are being followed. So this is without landscaping. Now, once the landscaping was done, then you can see that the blue patch, yellow patches are removed, and those areas have become now shifted from category E and D into categories C or B. So that shows the effectiveness of landscaping. Now, this is another interesting experiment. So here, the same model has been tested for the winds of Auckland on the left-hand side, and the right-hand side, the same model for the wind at Delhi. So you can see here, for example, here you have some yellow patch. So this cluster will not be allowed to be built in Auckland, but it will be allowed to be built in Delhi. So similarly here again, this area has become very dangerous in Auckland. That's because the wind speed is much higher in Auckland. And then this is for different activities. What are these categories? See, this is Weibull distribution in which different categories are there. So if it is category E, dangerous to pedestrians. E means what is the wind velocity? It's more than 14 meters per second. Okay, so this is how we actually put the whole thing in the Weibull distribution. Now, for the research, it's not sufficient if you. So one way is you need to, like what Madam was saying yesterday, that when you compare your work with other researchers, if it is similar, that shows that it is in agreement with most of the accepted research. So sometimes it may not. But here, like I had to take around so many different countries, what are their wind comfort categories. So like British Research Establishment, Canada, then Japan, France, Denmark. Denmark, there's a consortium of 6 or 7 countries, states, and they have together come up with certain standards. Then New Zealand, the standard was designed by my guide, and Canada. So all these are put in this Weibull distribution here. And the one which I was proposing, that is in the red circles, and the others are by the other researchers. So here there's some differences. The differences is because of the probability of occurrence was different by different researchers. Somebody took 10% as the probability of occurrence, somebody took 20% of the probability of occurrence. So depending on that, the Weibull distribution is varying. So this was the important result, which was more or less agreeing with most of the work done by the researchers from the other countries. So these are some of the references. So that's it. So thank you.
You can stop share. Created a presentation with all the experiments that you've conducted. So I'll open the session for questions, taking up questions. I request all the participants to come forward with your questions or any queries if you have. You can switch on your camera and ask the questions.
Good afternoon, sir. Can you hear me?
Yeah.
Hello. Sir, I have a question. Thank you so much for your presentation. It was very nice and to hear you. And one thing was very different from the other days. It was like you talked about this creative visualization. And I have a question regarding that. Like, do you think this creative visualization thing can be used as a tool for generating a design or a research hypothesis? And how do you see that thing actually?
See, I'll tell you one thing. If you're doing a PhD, what is it that you want ultimately? You want that degree, okay? And when do you want it? You want it in 2 years or 3 years or 5 years or 6 years or 7 years? There are people who get their degree in 7 years. Some people do 5 years. But you want it in the shortest possible time. So how can you get it? So this technique you can use even for that. So if you attend a PhD, convocation, then you know how the whole thing is happening. Okay. So like you're doing your PhD, but before the actual PhD, you can close your eyes and you can visualize. And then what is going to happen, you can visualize that you're wearing a red gown and then you're walking straight and then you're turning right. And then you visualize that your vice chancellor is reading your name. You do that rehearsal. So what is happening? That picture gets planted in your brain. I did this rehearsal 4 times. Same thing happened. No, I got it in 2.5 years. I'm just telling you a technique, like it's not just for PhD or research, anything in life if you want. You want a car, close your eyes and then visualize you are driving the car and you're pressing the brake and the accelerator and actually feel as if you have achieved it. And that picture will become real. If you don't have that picture, then it won't happen. Suppose
Yeah.
say, I'll tell you what, I went to the net and I downloaded the wind tunnel picture. And there, the actual testing which was being taking place and all. Then I closed my eyes and imagined I am actually doing the wind tunnel testing. I showed you a photograph, no, where I'm sitting in the wind tunnel. That I had visualized before. It happened. It will happen. So if you're, I mean, I think this is not given in your research methodology text, but this is how you can quicken your work. Simple example, there is one of the participants is my friend Naveen Gore from Geetam. So when we are writing a paper, I told him some technique. The first thing that you send to any journal is the abstract. Okay. So even without writing the full paper, if you have finished the abstract, you put it in the format which is given by the people and you write your names. So, and then look at the abstract and then close your eyes and imagine that the paper is completed and it has been printed. And then it will happen. We did that technique also. Like we wrote our names, even without writing the whole paper. Wrote the names, title of the paper, then we wrote the abstract, then we wrote the keywords, and that is the front page, no? And then we visualize that abstract is accepted. We also put our photographs, because in the end you have to put photograph of the author. Paper is not complete, but we have put the photographs, we have put the abstract, visualize. Paper is accepted in the international conference in Raipur on housing. So, and this is off the record, what I'm telling you. You follow whatever your researchers are telling. And, but it's always, visualization is a very powerful tool. And if you do it in a creative way, then it will happen.
Yeah, thank you so much for this very interesting, insightful thing that you told me. I'm actually thinking to go for a research, so I just finished my master's, so that can be very helpful actually.
Now, I use this tool before I took students to 9 countries. I standing in front of Burj Khalifa, I stood there, Petronas Towers, Byzantine, wherever I wanted to go. First, I visualized that I'm standing in front of that place or that building or that country. It happened.
Thank you
You
so
can also
much.
try it and let me know.
Yeah, for sure. Yeah, I will let you know. And I have another question also. It's very different from the other question, because you were talking about this ring testing and these things which are mechanically done. And do you think right now the softwares are very powerful and we can do everything in the simulating softwares that is what we call optimization these days? Like, is it possible to do it there, or do you think the mechanical has to be?
Yeah, you have to use CFD because wind tunnel testing is very expensive. Everywhere you don't have these wind tunnels. So you need to use CFD, but then you have to be very careful with the boundary conditions. Like I told you, slide this thing. It's like, power steering. You're driving a power steering car, no? Slight wrong turn means the car will go off in another direction. And you may crash. So if it takes time to learn CFD, but here let me tell you one thing: whatever your software you are using, if you know the theory behind that and the science behind that, then it will be very easy to do that. I'll give a very small example. In urban design studies, they use some software called ISOVist. So this ISOVist will help you in mapping when you're walking in a street, all the different views that you would be encountering can be easily seen in real time using this ISOVist. But that same thing can be done manually also. Like you make a plan of those buildings and then you draw the coordinates on the cone of vision. You can do it. But that cone of vision keeps changing as you're walking. And in urban design, like the vistas and views keep changing when you're walking in a street. So how that can be done? By using this ISOVist, you can very easily do it. But then this software, if you know the basics, how it is operating, although I'm not an urban designer, I know the basics of urban design. So I can easily understand the software and use it. But without knowing that, if I use that software, it's of no use. So many of these softwares, even without using that software, if you have some basic funda, you can do the calculation. Like I use the software like Radiance, for example, for lighting. And using that, finally, you come to the conclusion that 25% of the room will get light. But even without that software, if you have some basic idea, some thumb rules, you can get the same result. But we have got caught up with just like you want to do 5 plus 7, how much you use calculator. But before we never use calculator, no? So like that, there are many things which you can do very fast without software. But software can help you, like CFD can help you, because otherwise you have to solve those Navier-Stokes equations. It takes a lot of time. So CFD does everything. What would take you 10 days, it will do it in 1 hour.
Yeah, thank you. Thank you so much for answering these questions. And that brings me to a little small follow-up question. Like, I'm just curious about it that do you think then in research there is a place for intuition too? Like, can you use our intuition?
You speak loudly. I'm not able to hear
I'm
you.
asking, I wanted to ask that, do you think in research there is a place for intuition also, in somewhere we can place our, like, is it possible?
Intuition.
Yeah.
Yes, 100%. Because let me tell you, you read some books of how great discoveries were made by scientists. Many scientists, you know what they do? When they're sleeping, they'll put a pad by their side in the night. Then suddenly by intuition, they'll get the solution. They get up in the night and they write it. That is how the periodic table, the scientist who was working on that, Medvedev, he slept, and then there was one element he did not know where to put it in the periodic table. Then he slept, and then suddenly by intuition he got the answer. All the great discoveries were made by intuition. See, in architecture we have two things. One is we follow a systematic method of design. Second is the intuitive method. So systematic method coupled with intuitive method, because when you're using intuitive method, your subconscious mind is also part of your design. So when you're working on your design, for example, you're doing it in the class. In the class, you are fully conscious. But then if you're thinking about the problem, even when you go home, it is incubating in your mind, and suddenly you may get a very creative or original solution. Something like Frank Lloyd Wright's falling water. So like that, intuition is very, very important. Many of the scientists, they have made discoveries because of intuition. Because there is a higher power which is accessing your problem. And one of the best examples is the Ryoanji garden in Japan, landscape garden, where you have an arrangement of 7 rocks, and a monk would be sitting at one point and meditating. And what they have shown is that when a monk is sitting at that particular position, he is getting a very calm and serene feeling. Why he is feeling like that? A lot of research has been done. Tokyo University has visual arts department has done a number of experiments by changing the location of the rocks, position of the rocks, and also the position where the monk was sitting. And they found that this feeling is not coming with those other arrangements. So what is the final conclusion of Tokyo University? It is published in Nature that this was a subconscious act of design, not a conscious act of design. When a monk was meditating, he went to a higher level of consciousness. Then he saw the arrangement of these 7 rocks, and that's how this Ryoanji garden has been designed. So you can also visit Ryoanji garden in Kyoto and experience for yourself. Sit on that point, you will feel very serene. You sit somewhere else, nothing happens. So that's how your intuition, subconscious. See, intuitive method can make the design very, very, creative. Otherwise, everyone follows the same systematic method, your design will become like the same thing, what everyone else is doing. That creative spark can come only from intuition.
Yeah.
Oh, Devashish, any question before other participants ask?
Yes, sir. Sir, I do have certain questions, like particularly for the wind tunnel experiments that you told. I just wanted to know, since we are simulating the models, the strength of the structure, which is actually using a certain kind of a material. In the wind tunnel experiment, we do not replicate the same material. We use
No. There are some things called the law of similitude.
yes, sir.
So like you're trying to, there is a like part will be also telling you about time series. So the time of the experiment inside the wind tunnel is you're doing the testing for say 1 hour, 1 minute. 1 minute the wind flow would be equal to 1 hour. So you are using similarly the there are certain straw hull numbers and all that. So material, the density of that material and the actual material, that's a law of similarity or something like that. So suppose say I'm using the erodible material, I use sand. The density of sand will be much more than this bran. So then I use styrofoam. That styrofoam might not be able to withstand the these erosion patterns. So I might have to change it to some plywood or some other model. But so all these things, what they do is they calibrate the whole process first. Like I make a model. Before putting the model in the wind tunnel, I take this bran and I spread it on the surface of the turntable. At what velocity the bran particle is lifting off. Sand will lift off at a different velocity. Bran will lift off at a different velocity. You can use popcorn also. So all these different materials can be used. Then when you put the model and then at what velocity the particle is lifting off, that is called threshold velocity. So suppose without the model, the sand particle lifted off at 2.5 meters per second. After putting the building, if it is lifted off at 1.5 meters per second, that means some extra force has been given. So who is giving that extra force for it to lift off? The building is amplifying the wind, the building configuration or the Venturi effect or the downwash. So these are the building induced winds which are amplifying and causing uncomfortable or dangerous conditions for pedestrians. So how these things can be rectified? See, simple example is, suppose you go to a city like Wellington. In Wellington, the minimum wind velocity is 15 meters per second, which is the dangerous. Now, if you're building a new development like apartments or something, they cannot tell you that they are not creating the wind. No, they cannot say that we cannot have 15 meters per second wind. So their bylaws are saying, if you're designing a new building, first see what is the existing wind conditions in that particular developmental project, and then do wind tunnel testing and give the new wind velocity profiles. If that is more than 15 meters, then you are not permitted. It should not, deteriorate the existing wind conditions, because it's very windy city. Anyway, what you are asking, that material, there are all some scales are there. What's, say for example, I'm not making the actual building. No, I have to use 1:400 scale. So what scale to make there, and what scale that there are some obstruction blocks. Those blocks are simulating the actual buildings. So there are some wind tunnels where those blocks can be increased in height, reduced in height. In Toronto, it's there. So I want some high-rise buildings in the middle of high-rise buildings. Then what happens? Each building will be blocking the other building. You won't get breathe at all. So how much of the building is blocked? There is something called interference effect. One building may interfere with the wind effect on another building. Then the outline, the configuration, whether it's a streamlined shape or whether it's a bluff body or pointed corners, all these are very important. So architect, if he wants to modify the thing, he might chamfer the corners, he might streamline the shape. These type of things you have to do.
Yes, sir. I think that is why probably the wind tunnel experiment is so expensive, considering so much of scalability has to be factored into different factors like the wind speed, the materials, and then the erosion element. Everything has to be taken care in terms of the scalability.
Okay, my meeting is starting at 3 o'clock.
Yes, sir. Yes, sir. So, any more questions? You can put it in the chat box, or if there is any quick question, if anybody wants to ask. Okay, so with that, we can wrap up this session. Anita ma'am, over to you, and we can start the next session at 3 probably.
Yeah, okay, we can start it at 3 p.m. Participants can remain connected.
Okay, I'll leave now. Thank you all for your patient listening. I have a meeting at 3. So I'll
Yes,
leave.
sir.
Thank you so much, sir. Thank you, sir.
I request all the participants to switch on their cameras. We'll have a group photograph that will be considered for the attendance for the first session today. I request all participants to switch on their cameras. Okay, thank you. So we'll start the next session at 3. we'll just set up the presentation for the next session and we'll begin at 3. Hello, sir. Nand, sir.
Yes,
Yes, sir. We can set up the presentation.
no issue. I will share. Huh?
Yes, sir. Yes, sir.
Okay.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Ji Misra ji, good afternoon.
Yes, sir. How are you, sir?
Sir, you can download it and you can present it in full screen, or you can open in a new window.
Hello, Parth. Is my screen is visible?
Yes, sir. Yes, sir.
Okay.
You can make it full screen, sir.
Okay. It's okay now.
Yes, sir. Just run 1 or 2 slides, sir, for checking.
Yeah.
Yes, sir.
Working.
Yes, sir. Yes, sir. Working.
एक बार ये बोल।
So we can take a small break of 5 minutes and we'll start at 3 p.m. sharp. Today's session might be extended a little bit, 10-15 minutes towards the end. So we can have this short break and return back by
Sir, shall we start? Nand Kumar, sir,
Yes.
shall we start, sir?
Yeah, no issue. Ready?
Now the second session of day 3 is by Dr. Nand Kumar, sir. Dr. Nand Kumar, sir, is an associate professor at the Department of Planning and Architecture, MNIT, Jaipur, Rajasthan. He has completed his Master of Urban Rural Planning and PhD, Architecture and Planning from IIT Roorkee and BArch from MNIT, Jaipur. His research interests encompass various facets of urban sustainability and development in the realm of urban transportation, innovative solutions to enhance mobility while reducing congestion and emission. He also aimed to contribute to the development of cities that are resilient, environmentally responsible, and beneficial for their inhabitants. Today, in this FDP, he is mainly focusing on the topic research methods and techniques in planning. Sir, welcome, sir. Welcome to this FDP.
Thank you, madam. Good afternoon, everyone. Am I audible, ma'am?
Yes, sir.
Yes.
Good afternoon.
The screen is also visible, sir.
Okay. So I think today is the third day this FDP is going on, and participants have done various research methods and their techniques. They have studied various programs. Today I want to discuss what are the planning techniques and what is research. So I think in these 3 days you have studied what is research. Research is a systematic process. I want to discuss the overview of the research using scientific method to generate new knowledge, improve existing systems, and solve problems often published in academic journals or contributing to the general knowledge. So in the research generally we use scientific method and certain methodology we have to follow. Without methodology, just like that, we cannot go in the research. Research by the design in architecture and planning involves expressing qualitative aspects of the world and adding new knowledge through experiments and proposals. Here, qualitative aspect is important in the planning. See, in architecture, we can study the quantitative, sometimes qualitative aspects. So how to analyze the qualitative aspects, how to consider the qualitative aspects in the planning domain, that we would like to see. So what are the techniques and tools are available for planning that these qualitative aspects can be incorporated in the planning research. Then what is the importance of this planning research? When we are doing this planning research, it is helpful to in the decision making, understanding complexities. See, our system is very complex. In that, to understand that system, this planning research is very much important. And community insights. Through this research, planners gain insights into the community needs, preferences, and their trends. Through this planning research, we can optimizing the resource allocation. Otherwise, allocation of the resource is not possible. So that when we do this planning research, this allocation is possible. Then the evidence-based approach, it increases an evidence-based approach, reducing the reliance on assumptions and enhancing the credibility and effectiveness of planning decisions. And for continuous improvement, planning research is also important, and for community engagements and long-term vision. So these are the things for which planning research is important. Therefore, how we should do this planning research? What are the research, different types of the research? First is descriptive research. In the descriptive research, mainly we are taking the observations, surveys, and through the case studies. And in the analytical research, we are examining the available data to authenticate and support ongoing research while generating novel ideas. In this analytic research, we can generate the new ideas. And the third is applied research. In this, we are finding some practical solution, what is applicable. And next is the fundamental research. Mainly fundamental research is related to theory or understanding the natural phenomena, contributing broad application to existing concepts. Next is quantitative research and qualitative research. These are related to qualitative and quantitative aspects. In this quantitative, we are taking the numbers, numerical data, and then we are analyzing and we are using for that. Next is the conceptual research. In this, we certain developing a concept, certain methodology development is there. And in the last is the empirical research. It focuses on first-hand data collection, observation, experience to confirm or invalidate hypotheses, allowing researchers to manipulate variables to examine their effects. So these are the different types of the research. It depends upon your topic, what kind of the research is going on. Okay. Then this research is related to planning. So what is planning? I think everybody understand how to define the planning. And when we are working with these 6 domains, people, their activities, their space, time and resources and technology, all these 6 are interconnected and interlinked. So we have to organize all these 6 parameters and we have to study. That is planning. Organization of all these 6 components, that is planning. People, activities, space, time and resources. In people, we consider the demographic aspects. In activities, the infrastructure related things. In the space, overall development, planning concept. And the time. See, in the planning, time horizon is important for that. That planning is for 5 years, 10 years, 20 years or 30 years. It is a development plan or it is a prospective plan or it is your PhD research. So timeline is very important in the planning research. Then the resources, what kind of the resources are available for planning? And finally, the technology. Technology has the major role in that. All these 6 parameters are interrelated or interlinked. Once we will study, then what are the different planning techniques? Number of the planning techniques are there. It depends upon the what is the requirement of your study, what kind of the tools and techniques we can apply in that particular research. So mainly these are some broad planning techniques. One is system dynamics. Second, GIS and remote sensing techniques, cost benefit analysis. Some are statistical tools are there in that. Sometimes we are performing correlation, regression, cluster analysis, factor analysis, AHP, analytical hierarchy process. One of the planning techniques, with the help of the SWOT analysis, we can also frame the guidelines. We can also conclude the decision related to that. Then the land suitability analysis. When we are preparing the master plans or the development plans or any land suitability analysis, we can perform in that. At that particular location, what kind of the land usage will come. In that case, this land suitability analysis is very much useful for us. The next is the threshold analysis and projection techniques. See, in the planning, population is the important parameter, and to project the any data, we need different types of the projection techniques. To project the population for next 30 years or 40 years, we have to use the infrastructure or any other requirements. So we can use these projection techniques to forecast the future requirements. So as per the requirement of the study or the work, we can choose any one type of that or maybe multiple type of the planning techniques, and we can carry out that research or that planning exercise. So today I want to discuss system dynamics. What is system dynamics? A system may be defined literally as an organized or complex whole, an assemblage or a combination of things or parts forming a complex of unitary whole. System concept has had a substantial impact on both the planning and the execution function of the management. See here, the system impact is there on planning and management, both the things are there. This effect is best illustrated in the planning context by increasing emphasis which is being placed on scientific analysis of the managerial decision. So this system dynamics tool can be applied in any kind of the research, maybe in the medical research or in the managerial research or in the planning research. It is very much important tool. What is system? All the subsystems of the systems are interconnected and interdependent to each other and forming a system. So this is the beauty of the system. All the parts of the system are connected and interlinked. A system may be static or dynamic. It depends. In a dynamic system, if one of the subsystems or a combination of the subsystem of the system defined or functions with a higher degree, taking a lead role during its function, its effects can be visualized in the entire system over a period of time. So system dynamics is a methodology whereby complex dynamics or non-linear interactions in the social systems can be understood and analyzed, and the new structures and the policies can be designed to improve the system's behavior. Here the beauty of the system dynamics is to analyze the non-linear interactions. Otherwise, in other systems, we cannot analyze these non-linear interactions. It is very difficult to analyze the social system. So here the system dynamics tool can analyze the social systems, and this social system is very complex. So in this system dynamics techniques, we can analyze this complex system. In other techniques also we can do, but we cannot reach up to that level, whatever the accuracy is required in that system. So here in this system dynamics, this is one of the best tool that we can apply at the social system level. So in urban planning, this is very much appropriate tool to apply and to study to how to apply these system dynamics techniques in urban planning problems. So what is urban system? Basically, urban system consists of 7 subsystems, that is physical, social, economic, ecology, environment, infrastructure, and institutions. These are the 7 subsystems. They are interlinked or they are interdependent. Then this will be called a system, urban system. If one of the subsystem, maybe the social subsystem is defunct, some problem is there, then the problem of this social system subsystem we can see in the whole system. So because all the subsystems are interlinked, so the output of one system will be used as an input in another system. So we have considered this urban as a system, and that consists these 7. When we are using this system dynamics techniques, we have to model. So how to model? What is model? How to define the model? A model is a replica of the real system. According to Lee in 1973, the application of system dynamics models is the best option in understanding the real world situation in an urban system. To understand the urban system, system dynamics is the best techniques, because this is a real system. We want to understand the use of the models within the planning process, therefore would seems to be relevant to understand the behavior of urban system and to elaboration of alternatives. See, in this we can forecast the system. The forecasting is possible in system dynamics techniques. So we can perform the modeling in this whenever we are doing the modeling exercise or we are making the model. First we have to define what is the problem, definition of the problem. After defining the problem, we have to formulate the initial model first, and whatever the initial model we have prepared, after preparation of that model we have to validate, model validation, and then after validation again we have to reformulation of the model. Suppose some corrections are required at the time of the validation, that validation is not perfect, in that case again we have to reformulate that model. Then after that reformulation of the model, we will do the model simulation, and finally we will apply that model. Okay, so this is the process of the modeling. Any kind of the modeling, we have to define these stages, and this is applicable to all kind of the modeling process. These are the steps in system dynamics modeling that we have discussed. Okay, first we are conceptualizing the problem. What is the issue? What is the problem? What we want to achieve? According to that, we will decide or we will fix the model boundaries and their aggregates. Then based on that, we will detail out building the detailed model. Based on this conceptualization, based on this model boundary, the detailed model will be prepared, and that detailed model will be validated. After validation only, we will create scenarios or we will do the simulation exercise, and finally we will analyze and designing the policies based on that. Whatever the model is giving result, based on that result interpretation, we will design the policies. So in model validation, once the initial formulation of the model has been completed, its ability to reproduce the characteristics and behavior of the real world system must be tested. Without testing that model, initial model, we cannot use for forecasting. So before forecasting, model validation is necessary. Otherwise, it won't reproduce the characteristics and behavior of the real world system. And then after that, we will do the forecasting. If the model is used for planning, once the model is developed, validated, projections has to be made according to the requirements. Project the model to arrive at the projected year model. Suppose the projected year model is 2041 or 51. The projected year model has to be used for simulation or application mode or application. Whatever the forecasting model is there, that model will be used for simulation purpose, for various scenario generations. In this, different alternative plausible scenarios shall be developed based on the historical events, time series analysis, trend analysis, or assumptions, and same may be also tested in the model. Both optimistic and pessimistic scenarios may be developed and tested individually and jointly to arrive at plausible policies. So here, after doing this simulation, we will arrive the decision of policies. So in the analyzing and designing the policies, we will see the suitable results. What was the result of the base year model? Then the projected year model and the simulation result will be considered, and through interactive analysis shall be made. All these three results we will use to make the final outcome. The results of the analysis will be further examined judiciously to arrive at plausible recommendations. These recommendations shall be made useful to design optimal and feasible policies. So, for these system dynamics techniques, we will use Stella software. Stella means Systems Thinking Education Learning Laboratory with Animation. Okay, in this Stella software, there are 4 components. One is stock. In the stock is a generic symbol of everything that accumulates or drains. Okay. Next is the flow. A flow is the rate of change of a stock, where the change is taking place. In a bathtub example, the flows are the water coming into the bathtub through the faucet and the water leaving the bathtub through the drain. So you have to see what is stock, what is flow. Then next is the converter. We have to use the converter and connector. Stock, flow, converter and connector. These are the 4 components. We have to understand what is that. So a converter is used to take input data and manipulate or convert that input into some output signals. In the bathtub example, if you were to turn the valve that controls the water flow in your bathtub, the converter would take as an input your action on the valve and convert that signal into an output reflecting the flow of water. And the last is the connector. A connector is an arrow that allows information to pass between converters and converters, stock and converters, stock and flow, and converters and flow. In this figure, we can see how this stock, flow, converter and connector has been shown. So these 4 things we have to use in this Stella software. This is shown in this causal loop diagram. Basically, in the system, the beauty of the system dynamics is causal loop diagram. Cause and effect relationship. If something is happening, there may be some reason. So some circle will be there, some loop will be there. Without loop, you cannot apply system dynamics techniques. So first we have to prepare the causal loop diagram. Cause and effect relationship we have to establish through our research, through the literature, through the past work. If urban heat island effect is there, then what are the reasons behind that? Why the urban heat island effect is happening in the urban area? What are the factors are affecting that? So we have to find out the cause behind that. The paved area is the cause, or using the more AC is the cause, or behavior of the people is the cause. What is the root? Or maybe the less green spaces in that city, or due to the climate change. We have to find out the cause and relationship. So here the cause and effect relationship is important, and the cycle should be completed. If the cycle is not completed, then we cannot apply this. So we can find out the parameters which are affecting that particular problem, which are responsible for that particular issue. So that can be analyzed in this Stella software. So first we'll prepare this causal loop diagram, and then finally we'll take these diagrams in the Stella software. This is the representation of this quantitative analysis in using system dynamics. This how to show this stock and flow, a general structure of that. Stock, then flow, then outflow is there. This is the equation which is showing stock at certain time. Then what is inflow, then how much is outflow at that particular time. That is shown in this equation. So whatever the data we are feeding in this software, that will show in this equation. And this is the graphical representation of this Stella software of stock and inflow and outflow. In this, generally we use these levels, rates as a variables, delays, table functions, auxiliaries. See, here again, the beauty of this system dynamics is to take the table functions. Whatever we are thinking, whatever the idea is there in our mind, that we can convert in the table form or in the graph. From that graph, this software will read the data and analyze what is the behavior of that system. Otherwise, in other research, we have to give some numbers. Here, you don't have the number, but you have the trend. From that trend or based on that behavior, you can plot. If this will happen, then what will be the effect of that? So that can be analyzed in this system dynamics software. So this table function, these delays functions are very much important here. Suppose you can see the one of the example of Bangalore city. Suddenly around 90s, Bangalore city's population have increased due to this software policies. It has given lot of benefit to soft companies. Due to that, influx of people have came to Bangalore city. The population has increased. So that behavior can be analyzed in this software, in this by using this system dynamics techniques. Once what will be the effect of that policy if this much of the initiative will be given, then how that affect your employment or population, and due to that population influx, what will be the effect of in our systems. Urban level 7 subsystems are there. So once they are interlinked and interconnected, so definitely the effect of one can be seen, or maybe the outcome of that can be used as an input of a subsystem. So when you see what is physical flows, levels means accumulations. Our stock is level basically, and the rates. So these are the variables as shown, flow of the material. These are the physical flow, and in the levels, raw material inventory, that is the stock. And rate is material shipment rate or goods receipt rate or production rate. So you can see what is the difference between flow, level and rate that we have to use in this software. We want to take one example for this system dynamic software in energy management in Jaipur city. We have identified some problems related to energy. You know, everywhere the energy shortage is there. At urban planning level, so energy management at the city level, system dynamics techniques has been used. Stella software has been used, through which the forecasting, through which the policies has been made. So these are the problems we have identified through the study area. Once we'll go through the study area, we have observed these are the problem with the shortage of the energy. So how to fulfill requirement? That any other statistical tools also, correlation, regression, but finally we have decided to use system dynamics techniques because urban is a very complex system. It is a dynamic, it is not a static. 30 years, 20 years, 50 years, prospective plans, development plans, policies for that. So how to go ahead with that? So with the help of this example, I would like to explain how this system dynamics techniques can be used in energy management. So that was these are the objective of the study. In this, to study the existing condition, what is the existing system, which we are doing in the research. Then to quantify the energy consumption pattern in the system, to identify the control parameters through the literature. We have identified what are the control parameters which are affecting the energy consumption at the city level. And finally, to forecast the demand and supply in the next 10 years. And based on this forecasting, to make the policies to manage the energy at the city level. So these are the objectives we are framing for any kind of the research. We are doing the study of the existing system. We are doing the study of the parameters we are affecting. Then we are doing the study of the model, and then based on that modeling, we are doing the forecasting exercise. Because in the planning is always for future. Same time, we have to start to analyze the existing system also. First, we have to meet out the existing problem. We have to solve the existing problem, and then we have to go for the future exercise. So we have to study the existing system. Through the existing system, we will know what is going on, how much shortage is there, what are the systems of energy generation from the, what is the consumption, in which sector this energy consumption is going on. All these things we have to study from existing condition. Okay. And based on this, we have developed some hypotheses, some concept. Here the system concept has been employed in present this investigation. And we have studied a system function as a whole with the interaction of several subsystems. In this urban subsystem, all the subsystems such as physical, social, economic, ecology, all 7 systems are together function as a whole in this present investigation. Here also this study area is considered a system. First floor, first page. And then based on that, we have decided the research design. Here the survey research method has been employed. See, to collect the study area data. How to collect the data? Primary source and the secondary. The secondary source data is available, the old data is there. And in the planning, we need the current data. And the household level data is not available. In that case, we have to go for this primary survey, qualitative and quantitative. Both kind of the survey we have to conduct at the household level, at the city level. This is the general methodology for any research. You are identifying the topic based on the literature. Then based on that, you are developing the hypothesis, scope and concept. And from the literature, you are identifying the control parameters. Based on that, we are collecting the data, primary and secondary, analyzing that, modeling, forecasting, model validation, then forecasted year model, application of the model, results and discussion, finding, evolving policies, and finally conclusion. This is the standard methodology. As per the requirement of the research, you can change. Here, the modeling technique is system dynamics. We have used Stella software. For other research, you can use different kind of modeling techniques for that. You can also use GIS. You can use some other tools for that. Okay. You have to see what is the requirement of the research, what kind of the primary data, what kind of the secondary data you have to collect. Without the data, it is not the standard methodology for primary survey, primary data collections. That you will study, I think, in next session or maybe tomorrow. This is again what kind of the survey techniques, sampling methodology we have used. That is very much important in the planning research. Here we have used the stratified random sampling methodology. And that is the one of the best methodology to study for primary survey. It is very difficult to collect through this methodology, but this is the by which you can collect the best data, by which you can represent the whole system. That is more important. There is no biasness in this stratified, this random sampling methodology. Okay, based on this primary survey, we have prepared the tables, graph, pie charts. So here I am showing you the one final table based on here. My objective of the research is to find out the energy consumption at the household level. What is the total energy consumption at the household level by using the domestic appliances? Because the title of the research is to manage the energy management plan, to prepare an energy management plan for Jaipur city. So without knowing the system, so how to capture the real system? We have gone through that primary survey, prepared the survey performa, collected more than 500 samples, and from that survey samples, we have prepared this table. In this table, we are showing the data, how much is the energy consumption in the different sectors, in various sectors at the household level. What is the per capita energy consumption at the household level? Because this per capita energy consumption will guide me to make the policies I want to see. And same time, this energy, this income is affecting your energy consumption. So here, income is the one of the most important parameter. So we want to capture this income level. What is the income level of the various households, and what are their energy consumptions? As the income is increasing, how their energy consumption is increasing. So through the primary survey, you can find out this data from the secondary sources also. But you have to see what is the authenticity of that data, who has collected, what are the methodology has been followed for that, and what are the tools they have used to analyze that data. So here, based on that primary survey, we have captured this, and this data we have used in the model. See, without knowing this present situation, how we can forecast for the future? Therefore, here the primary survey is important for us. So this primary survey has been done. Based on the analysis of this primary survey, we have used this data in the model, some data from the secondary sources, some data from the primary, and based on that we have forecasted. Based on this data, first requirement of energy management at the city level, we need the population model. Population, we want to know what will be the population in 2031 or 2041. There are some stable methods are there. You can use those methods. Arithmetic increment, progressive increment method, core and component methods are there, graphical increment methods are there, ratio methods are there, number of the methods are there. Here system dynamics tool has been used to forecast the population in 2031. So here you can see we have studied 4 components of this or elements of this system dynamics. One is stock. Here stock is the population. Population is the stock. Birth and death rate you have to see. population. Population is a function of birth rate, death rate, in-migration or out-migration. 4 parameters. They are affecting your population. So we have captured these 4 parameters. Same time, your household size also, and density of that city, and same time attractiveness index of that city. How that city is attractive, what kind of environment in that city. That is also indirectly affecting your population in-migration rate or out-migration. Your out-migration or in-migration is affected by the city attractiveness index. So therefore, in this population model, system dynamics model, population is the stock variable, and then birth, death, out-migration, in-migrations are the variables. They are affecting the population at the city level. So we have captured the behavior of urban system by taking the behavior of this city attractiveness index. Now, how to capture this city attractiveness index? We don't have any data. Then again, based on the table function only, we have calculated the city attractiveness index. So this is the one model related to population, and the second is related to this research for electricity consumption, because the research is related to energy management. So we want to find out what will be the energy consumption in 2031. So this model has been prepared to capture the total energy consumption at different type of the buildings, because at the city level, apartments are there, detached buildings are there, semi-detached are there, row houses are there. So 4 typologies are there. In all these 4 typologies, this energy consumption has been calculated. And this energy consumption is the function of their household size, their per capita energy consumption, their income level, their social standards, each and everything, they are affecting their energy consumption. So that is captured through this system dynamics software only. Then the next, finally, we have prepared number of the models, around 15 models we have prepared, and the last model is what is the overall impact of all these models on city attractiveness index. Due to that, the city population will increase or decrease. So the effect of all the models, चाहे वो population model हो, चाहे वो energy consumption at the household level हो, energy consumption at transportation हो, energy consumption in other sector or commercial or industrial, all the sectors, energy consumption and their environment impact, their CO2 generation, the complete effect has been analyzed in this model, and based on that we have calculated the index number. We have quantified, if this is the number, then this city will fall in that particular category. Okay, so this way we have prepared various models. See, these are the base year models. After preparing this base year model, we have validated the model with the literature data. Various variables we have taken in this model. We have taken 23 variables in this literature data, base year model data, and what is the percentage change. So here the maximum difference is around 7%. 7% variation is there in the literature data and the base year model data. So 5 to 7%, I think if it is below less than 5, then it is better. But in 2-3 variables, it is more than 5. Otherwise, most of the variables, they are less than 5. So now we can use this model for forecasting purpose, because we have validated this model with the past data from the literature. Population is available, city area is available of 2011, population density of 2011. Here we have considered the base year is 2011. And based on that 2011 model, we have compared this. So this validation has been done based on that. And based on this validation, we have projected various model for 2031. Now you can see population, energy consumption, electricity consumption, domestic electricity consumption. This way, finally, we have prepared 24 models, and final model is the city attractiveness index model. That is final outcome of this. So first model is the base year model result. Base year model result we have validated with the literature data. After validation, the same model, we have made some corrections. After correction, we have used that model for forecasting for 2031. Now, this is the result of forecasting model of 2031, starting from 2011 to 2031. In planning, we have considered 5 years intervals, phase wise, 2011, then 16, 21, 26, 31. And then we have prepared the table and the graphs. Okay, how this result is behaving. What is the characteristics of this various models, what they are showing. So then this way 24 forecasted model has been prepared. Then electricity consumption, this is also for 2041. So for all 24s, we have prepared these forecasting models. Now, after preparing this forecasting, we have to generate certain scenarios, or we have to do some simulations. These simulations we have done based on the past literature. So here we have made around 9 scenarios. In the scenarios number 1, we have done these things. Then the scenario number 2, again certain parameters. This way we have done 11 scenarios. 11 scenarios we have generated. Out of the 11, how to choose which one is the best? What are the criteria for that? So we have identified what are the important variables are there. Based on that important variables only, we have chosen, we have done this 13 simulation, and out of that 13, which simulation is giving the best results? So that best has been chosen based on the city attractiveness index. In which simulation this index is more? What is the behavior of the index? Now we can see this is the population model and this is the city attractiveness index model. In which simulation? So in all these 11 simulations, this simulation number 8 is giving the best result, in that our city attractiveness index is increasing. In base year model, you can see this, the city attractiveness index is the lowest, but when you are doing different types of 11 simulations, so the simulation number 8, that is giving the best results. So that we have chosen based on this index factor. So these are the findings of this scenario number 8 based on the city attendance index. In this, what will be the population increase, what will be the population density, what will be the electricity consumption, what will be the CO2 emissions in this. So this simulation, this policy is giving the best results. Then based on that, we have prepared the recommendations. In planning, we cannot recommend each and everything in 1 year. So therefore, these recommendations also has been phases out. for first phase, second phase, and third phase, 3 phases, and in each phase 5 years interval is there. So for what we can implement in the first phase, second phase, and third phase, according to that, we have recommended related to maybe this. See, this topic is related to energy management. So energy is consumed by the building sector. We know around 40% energy consumption is there in the building sector. So how to reduce that energy consumption? By making these passive measures, passive buildings, climate responsive buildings, by using some energy efficient appliances. Same thing by applying the ECBC guidelines. In the ECBC guidelines, it is mentioned to promote energy efficient buildings, to promote sustainable building materials where the energy consumption will be less. So at the city level, we have touched all subsystems or all the sectors of energy consumption, चाहे वो commercial, चाहे industrial, cooking, all the sectors we have touched. Then the transportation, how we can reduce the energy consumption in the transportation sector, use of the public transportation, change of the vehicles, and by using this solar photovoltaic, means generating the renewable energy. So how much renewable energy we can generate from solar photovoltaic? How much renewable energy we can generate from the solar solid waste management, municipal solid waste, or sewerage treatment of sewerage waste water? All parameters has been considered and they have been recommended as per the phases, first phase, second phase. Because in the first phase we cannot recommend. So it takes the time. Today we are making some policy. The effect of that policy can be seen after 5 years or 10 years. So it is not sudden, but something we can start suddenly also making some policies. So according to that, we have computed the result of this. What is the projected year model is that? Now you can see this is a projected year model of 2016, 2021, and what is the scenario result and what percentage change you can see here. So here the phase-wise recommendation has been given or related to all the parameters. So final model has been prepared for 2031. So 4 phases for third phase, all 3 phases has been compared with the scenario result of 2031. And based on that, finally, the most important scenarios which has given plausible result is identified, and further the result of this scenario is discussed thoroughly and plausible findings are evolved. The study concludes with evolving a set of energy management guidelines and recommendations. Further research is possible related to industrial and commercial projects. We have done broad, but now if we want to identify the project, in that case, the different research is required at the project level. Detailed project feasibility analysis shall be done to all feasible projects to implement the recommendations. See, whatever the policies we are recommending or we are making, some may be not be feasible. So we have to check the feasibility analysis. We have to prepare the detailed project report on that each and every project. And then finally we have to implement on the ground. So for implementation purpose, we have to again further we have to conduct the research. So here only we are giving the broad level policies. If this will happen, then this will be the scene after 2031 and this much of the energy consumption will required. So through this energy management, I have discussed the application of system dynamics, techniques. Other techniques are also there. You can use GIS also. What is the use of GIS in urban planning? Here we have used these GIS techniques to find out the public green spaces, how to distribute, what should be the size of public green spaces. For that purpose, this GIS techniques has been used. Application of GIS for urban planning purpose, we have applied this. Oh, I want to give only overview. This is the methodology we have used. So you can use any techniques. It depends upon the requirement of your research. Here, the requirement of the research is in the second case study to find out the site suitability for green space. When we are preparing the master plan, that time, how to allocate, how to distribute these green spaces, what should be their size, what should be their location. For that purpose, we can use the GIS. So GIS is also one of the best techniques for that purpose. Okay. So in this also we have identified certain criteria. Those criteria are based on the secondary literature only. And then based on that we have identified the parameters, and according to that the weights has been assigned, and then finally it has been converted in the GIS map. Different kind of the maps has been plotted showing the land surface temperature, then water bodies, green space, then slope analysis, road maps. So these are the different kinds of the maps required in the GIS software to analyze the requirement of urban green space at the city level. So this exercise has been done at the city level. Then the different kind of this overlay, weighted overlay analysis has been done. And finally, we have identified this site suitability for seeker city. This is the study of one ward. We have identified where should be the location, how it should far away from the roads and everything. And finally, we have compared with the UODFFI guidelines, master plan, zonal plan, and then see what should be the size of this public green space. And what is the ownership of that land. That also we can check on the ground and verify, and according to that we can allot. And the next is you can use the AHP also. Analytical hierarchy process also you can use in the planning, because sometimes some qualitative variables are very much important. In that case, we can go ahead with this AHP analysis also. So now I want to stop here. Thank you. Any question, anything, if you would like to ask? Hello?
Yes, sir.
Sir, from my side, it is over, sir.
Thank you very much, sir, for your insightful, detailed planning aspects and all. Sir, I just want to, before starting the question answer round, I just want to, for my curiosity, you have shown something about MCA, multi-criteria analysis, and again with AHP we can do with that multi-criteria analysis.
Yeah.
Now the the emerging field, that is special MCDM, with the help of GIS, how we can do the multi-criteria analysis.
Yeah.
So can you just elaborate something on that? That will be very much helpful to us.
By Misraji, I see my research scholars are working at, but I don't have much knowledge about that.
Okay.
Yes, I can talk about system dynamics. I can talk, but this.
No, I've just seen one or two slides on MCA, so that's why.
No,
that
is
is
fine. But
I am doing all these things on architectural heritage things, sir. How these things can be applicable? That is my curiosity. I have done some kind of 9 to 10 different types of MCDM technology, including the analytical hierarchy process, the critic, gray analysis method, COPRAS, TOPSIS, all these methods I have used. But my curiosity is how we can use all these things in the planning aspects with the help of GIS also. That is one of my question,
That
but
can be done.
okay, sir.
That can be done because that is the beauty of the GIS. We can
Yes, sir.
plug that variables, that weights also we can give in the GIS, and that can be analyzed. Also here also it is to allocate the site for these green spaces, we have used this multi-criteria analysis MCD techniques we have used. From the literature, we have find out the weights, then we are given in the GIS, and then based on that only we have allocated these lands for greens, public green spaces.
Yes, sir.
Yes.
Yes, now we can open the questions round for all the
Thank you.
participants. If Devashish, sir,
you.
please.
Sir, for the presentation on research techniques used in planning. And I think this is one presentation which was oriented towards planning exclusively with some kind of knowledge sharing on the idea of research and how to approach research. Anybody with questions can come forward and ask your questions. You can switch on your camera and you can ask the question straight away. Any questions?
जब सब गए तो लगता है
Sir,
कल क्या ऑनलाइन सिस्टम में यही तो ब्यूटी है, स्टार्ट करके चले जाओ.
sir, Nand Kumar, sir.
Yes, yes.
Sir, I just want to ask one question because this is something which is new for me because I am done my master's in architecture without much of knowledge in planning. Sir, when you talked about the scenarios, you said that there are different scenarios with the criteria changing for values changing for each criteria. Now, is it that one criteria that we're talking about changing one criteria and seeing how the other criteria behave according to that change in one criteria, or multiple criteria can change and a scenario can be created?
Yeah, see, once first we have created the base model. After the
Yes,
base model, we have created the projected year model. And from that projected year model, we have taken the different scenarios based on the literature. At a time, we can apply one tool. Suppose by changing this system, by maybe changing this policy, then what will be the effect on that system? Sometime we can club two, then finally we can club all the whatever the changes, whatever the scenarios we want to include, all the scenarios we want to include in one, and then we want to see the result. So it can go one by one, it can be clubbed together, or it can be go as a whole also. Okay.
Sir, yes, sir. Yes, sir. So how many, sir, this might sound like a very vague
It
question.
depends
but
how many
how many-
scenarios.
Yes, sir.
No, it is not fixed. It depends upon the time. It depends upon your system. It depends upon the kind of the research. See, when we are making these simulations, in the background, number of the computation and permutations are going, and you have to see how many are relevant for that. Sometimes somebody is doing only 5. You see, everything is not possible in the research. The number of the limitations are there. Time is limited. Your system is not responding. And then according to that, you will see what are the control parameters. So all control parameters you have to include in that simulation. If suppose by using passive measures or climate responsive buildings, or suppose 100% building will use the ECBC. Suppose in 2050, whatever the buildings we are constructing, those buildings will follow the ECBC guidelines. Then what will be the scene of energy consumption? If not 100%, 50%, 25%, 75%, we know 100% is not possible. So that way we see how much is possible. What has been happened in the past, last 50 years. We have made the policies, but only we have increased 5%, 10%. Policy is there to scrap the old vehicles. If the vehicle has crossed more than 50 years, we cannot use that vehicle. But the implementation is the problem in our system. So it takes time to send that vehicle out from that system. So in the planning, we have to see how much time is required to implement that policy. The sudden result is not possible. Once you will make the policy, the effect can be seen after 2 years, 3 years, not in 1 year. Only few policies that their effect you can see within 1 year. So it depends upon the type of the research. It depends upon the type of the problem, what kind of output, what is possible, what is the limitation of that. According to that, we decide only. That is not fixed. Okay.
Yes, sir. Thank you, sir.
Thank you, Devashish.
Any other questions, participants?
Good afternoon, sir. Sir, I don't know if I have missed it, but I would like to know the software you used for this system dynamics model, which you have explained in this presentation.
Stella software. A number of the software are some other nowadays. Some other software is also there.
Okay, sir.
Anna, you can.
Sir, can you give me some examples like software apart from Stella?
Sir, PowerSim is also there. Some other new software recently, 1 or 2 software has come. That so you can. This Stella is the old software that we have used in 2016. Okay. So
Okay,
now the new softwares are available that you can use.
Okay, sir. Thank you so much.
Any more questions, participants?
Yes. First of all, thank you so much, sir. Being your student, and it was a great pleasure for me to part of your lecture session again. Hello.
Thank you, Anjani. Thank you. Really, it is very good. Today you have joined.
Yes, sir. Thank you.
Really,
sir,
very
just,
good.
I have a regarding what are the limitations of this system dynamics way of analyzing this?
System dynamics has no limitation.
Okay.
You can use anywhere in the system dynamics, in the architecture also, in the planning also. Okay. And whatever you are thinking, that can be also plotted and that can be also computed in the system dynamics. And in this system dynamics, we can find out the relations, cause and effect relationship. And the beauty of this system dynamics is the causal loop diagram. And this system dynamics can analyze the complex system. And this urban is a very complex system and the dynamic. It is not a static system.
Yes, sir.
Okay. So therefore, this is more appropriate tool to analyze that, I think.
Okay, sir. Thank you, sir. Thank you so much.
Thank you. Thank you, Anjali.
I request participants to quickly come up with questions if they have any. Okay, so sir, one last question I want to ask because something which has looked very interesting was a causal loop diagram.
Yeah.
So when we look at a causal loop diagram, so is it for a continuous system? We are looking at a system that continuously changes or evolves over time.
See, you can use the system time for static also, for dynamic also. But in the causal loop diagram, the diagram should make the cycle should be completed. If the cycle is not complete, then we cannot use system dynamics. Means something is happening due to some reason. So
Yes,
that reason we can find out in the causal loop diagram. What is the root cause of that particular problem? I give the example of this urban heat island effect or maybe the pollution. So what is the main root cause of this pollution? So that we have to show in the causal loop diagrams. From that causal loop diagram, we can understand the control parameters. That control parameter will guide us to make this and to use in the system dynamics software. So first we have to develop the causal loop diagrams. Once you are clear about that problem, then you can solve it. And now the problem is that sometimes the data is not available. So here in this system dynamics, you can compute that whatever the literature is saying, some qualitative data is there. That qualitative data also we can convert in that quantitative data through the table function. One function is there, the table function that is known. So what is my assumption? whatever the my assumption is there, I can convert my assumption in the table function or in the graph function, and that graph will guide us. The graph will give the quantitative value to us. Qualitative ko quantitative mein you can change here. So, and based on your feeling, based on your opinion, if this metro will run, then after 10 years, this will be the scene of the development that can be computed. If this policy can be implemented, then due to that policy, the pollution will go away, or this population will increase or decrease. That effect can be computed in system dynamics through the table function. And that is not possible in other kind of tools. That I want to say.
Yes, sir. Yes, sir. Thank you, sir. It has been a very enlightening session. Any last any questions we can ask now, or we can end the session today? Over to you, ma'am.
If anybody have any issue, any problem, my mail ID, my number is also there. Okay, anytime you can send mail to us, or you can call to me. No issue.
Thank you, sir. Thank you very much for this informative and insightful presentation. The system dynamics technique was very well explained through the case studies, and it really helped us to understand the behavior of complex systems over time through the Stella software. I had come across this Stella software when I was studying the subject Dynamics of Systems Settlements in IIT Kharagpur, and it was like a recapitulating session for me.
Yeah. In IIT Kharagpur, lot of people are using system dynamics. My Guruji is also from IIT Roorkee, Professor V. Devdas, and the second person is Professor Virupakshi Bagodi. He's in the professor in Karnataka University. And both have studied from IIT Kharagpur. So their system dynamics is very much popular, and it is very much useful.
Yes, sir. So once again, thank you so much, sir.
Thank you. Thank you, ma'am. Thank you, ma'am. Okay.
Sir, you can stop presenting. And I request all the participants to switch on their cameras for 2 minutes so that we can take the photographs, screenshots for the attendance. I request all participants to quickly switch on their camera. Okay, thank you. I hand it over to Anita ma'am to say the ending notes.
Thank you, Debashish. So today is the end of day 3 session. And also I would like to inform you about the day 4 session. Since we have 3 sessions tomorrow, so we shall start at 12 p.m. sharp. All the participants are required to join tomorrow on the same Zoom link and 15 minutes prior to the session. E-certificates will be given to the participants who have paid the registration fee and are nominated by the institute under CTP and fulfill 100% attendance criteria, as well as scored more than 60% on MCQ test, which is scheduled on 12th January 2024 from 4:30 to 5:30 p.m. Attendance shall be counted individually for all the sessions scheduled during a single day. Thank you once again, and see you all tomorrow at sharp 12 p.m. Thank you.
Thank you all.
Hello.
Good evening, sir. मैंने वो draft भेज
Nand Kumar sir, you can stop sharing the screen. Sir, on the top, yes, sir. Thank you.